All right, guys, today let's talk about the Claisen condensation. This tends to be an Orgo 2 topic that you'll find in the chapters involving enols and enolates. I found this chapter probably to be the most difficult chapter in Orgo Chemistry 2. I hate doing it. It is intimidating. It is challenging. But I found that with using different colored inks and certainly numbering your carbons, it's a little easier to watch this mechanism kind of get placed together. So let's see if we can kind of walk ourselves through it. So it's going to involve an ester. Sodium methoxide is going to act as a base here. And of course, acid workup just means, hey, there's protons there if you need it to balance charges. So when performing this condensation, the starting ester must have 2 alpha protons. Okay, so we're talking about carbon 2 in this case. So the first thing that happens is base is going to come along, deprotonate this, and the 2 electrons, which did make up the carbon 2 to hydrogen bond, are going to kind of collapse towards carbon 1. And the reason is because there's a partial positive charge there, and then partial negative here, partial negative here. So this is just a negative attacking positive, right? So they're going to collapse towards carbon 1, creating a double bond between 1 and 2. That's going to be too many bonds coming out of carbon 1. It's going to drive this double bond up top as a third lone pair. So now we're at this molecule here. That third lone pair is going to come back down, reform the carbonyl, and then these 2 electrons which make up the pi bond are now going to act as a nucleophile. And they're going to bond towards another mole of whatever your ester was, specifically carbon 3 for the same reasons I mentioned earlier. There's partial positive there, partial negative, partial negative. Negatives love to attack positives. So it's going to form a bond of carbon 3 here. Of course, that's going to resonate up, become a third lone pair. So now we're here. Now, we learned earlier that esters make good leaving groups, and so as a result, this carbonyl will reform, and it's going to kick off that OR group, right? So that brings us right here, and then finally, another mole of whatever our base is, specifically sodium methoxide, is going to deprotonate this position here, and then we're going to kind of see a repeat of what we saw in the first step. The covalent bond, specifically the 2 electrons there, are going to collapse towards carbon 1, creating a double bond between 1 and 2, kicking this carbonyl up top to make a third lone pair, as you see here. This is one of the few examples where you will sometimes turn in a molecule that has a charge left on it. Now, this enolate right here, though, it is extremely stable due to the resonance between this oxygen and this double bond right here. And then, of course, this alcohol molecule came from when we kicked off this ester and protonated it and made it a neutral alcohol. And that is the Claisen condensation. If you found this video helpful, but you need more in-depth explanation and see a lot more practice problems worked out, you can find the full length version over at orgogo.com. Please like, comment, and subscribe to our YouTube channel. Help our videos find more students like you. Tell all of your friends you have a fantastic tutor. And if you're interested in private tutoring, or if you want a concept explained that you don't see on our YouTube page, shoot me an email, orgogoat@yahoo.com.